How do scientists find out the age of rocks on Earth? Well, you will know all about it in 5 minutes. Let's start our adventure. There are several different methods scientists use to determine a rock's age. These methods are superposition using index fossils and radiometric dating. One method of determining a rock's age is called superposition. First, you must know that sedimentary rock is a rock formed by many sediments. Sediments are pieces of rock, plant, and other material. Sedimentary rocks form in layers in lakes, rivers, and seas. The bottom layer is the oldest layer, while the top layer is the youngest layer. Because each layer forms after the layer below it has formed. So this formed after this formed. Basing off their knowledge that the farther down a layer is, the older it is, scientists get a good idea about how old each layer of rock is. But of course this isn't completely accurate because they wouldn't know how much time this formed after this formed. Another method of determining a rock's age is by using index fossils. Index fossils are fossils of organisms that were common and lived during a specific time. These are my best recreation of index fossils in Minecraft. An organism that lived during a specific time period was mostly fossilized into a rock around the same period that it lived. Therefore, scientists can use their knowledge of when an organism lived to tell when the rock its fossil was embedded in was formed. So these guys are the same age as this layer of rock. The other way scientists find the age of rocks is by use of radiometric dating, also called radioactive dating. This relies on the smallest unit of matter, an atom. Atoms come in different forms. Some forms are unstable and break down into another form after a certain amount of time. This breakdown is a very useful clock because the same atom breaks down into the same other atom form at the same amount of time. This breakdown is called radioactivity. So uranium-235 breaks down into lead-207. The rate of change of a radioactive element is measured in half-lives. A half-life is the time it takes for half the unstable atoms in an element to change to another form. So it takes uranium-235. It takes half the atoms in uranium-235, 704 million years, to break down into lead-207. Only half of the atoms in uranium-235. For example, take a look at this volcano. Let's say that first, this magma hardened into a rock. The rock contains some uranium-235, which is this right here. After uranium-235's half-life of 704 million years, half of the uranium-235 had turned to lead-207. So half of the uranium-235 turned to lead-207. And after another 704 million years, or 2 uranium-235 half-lives, 3/4 of the uranium-235 has turned to lead-207, and so on. This brings us to the year 2013. So now scientists know that this rock formed 1,408 years ago by measuring the amount of lead and uranium in it. They also know that these layers are older than the igneous rock, and these layers are younger because they formed after the magma volcano exploded, and these formed before the magma cut through. Well, that's about it. Thanks so much for watching.